Okay, so now we're going to look at these two problems. We're going to verify that 2x minus 5 and the function x plus 5 over 2 are inverses. And when it says this, verify that they are inverses, we want to use the definition of inverses. And recall our definition from the last video said that when we compose them together, we get x. And so we're going to compose both of the functions together and see if the answer to the composition is x. So I'm going to take f composed with g and do that calculation. So let's recall when we were doing compositions, whatever was first in the notation, we put parentheses into its x. So we would get that. And then we drop the second one into the parentheses. And I'm just going to copy and paste our second one. Drop it in here. Oops, no equal sign though. All right, now let's notice what happens immediately. Immediately, the 2's will cancel with one another. So then I'll have x plus 5 minus 5. And of course, the 5's will cancel with each other and we get just x, which is exactly what our definition says that inverses will do. Now, we always have to verify in both directions, so we have to do the second composition in the other direction. So let's do g composed with f. It too should lead us to an answer of x. So g, if we put parentheses into that x, I'm just going to copy and paste this right here. And I'm going to put parentheses where the x is. All right, and now let's plop f into these parentheses. So f is 2x minus 5. Now let's notice that we don't really need these parentheses here. They were just used to set up the composition. There's nothing in front of the parentheses. So immediately on the top of this fraction, the negative 5 and the positive 5 will cancel each other out. So we then have 2x divided by 2. Our 2's cancel, and now we have x. And we have verified that they are in fact inverses because both compositions lead us to x as an answer. All right, so let's do the same thing for these two functions. All right, so same idea. We are going to do f composed with g, and then we'll do g composed with f. So if we do f composed with g, we want to replace this x with parentheses. So we'll have 3 parentheses to the third power minus 12. And now let's take g and plop that into the parentheses. So I'm going to take this and, oops, it's not, copy and paste it, put it right in there. All right, so let's notice immediately the cube root and the cube on the outside cancel one another. So now we have 3 times, and let's see if I can just copy the fraction. The fraction, because the cube root is canceled out, minus 12. All right, so if we look at this, the 3 will cancel immediately with the denominator of 3. So now we'll have x plus 12 minus 12. And then the 12's will cancel, and we get just x as expected. Now let's do the other direction. If we do the other direction, g gets parentheses put in. Now I'm just going to copy and paste it first, and then I'll change that to parentheses. So we'll put parentheses into its x, just like so. And now f is going to plop into these parentheses. So we'll have 3x to the third minus 12. All right, now let's notice we really don't need the parentheses. We just used that in order to set up our composition. So here on the top of this fraction, our minus 12 and our positive 12 will cancel first. So now we have, with the 12's canceling, we have the cube root of 3x to the third over 3. So our 3's will cancel next. So if we do that, After the 3's cancel, we end up just having the cube root of x to the third, and of course the cube root and the cube cancel with one another, and we just get x.